Every 11 years, the surface charge of the Sun's magnetic field changes. At the apex of each solar cycle, the Sun's inner magnetic dynamo reorganizes itself. When the Sun's magnetic poles turn and billions of tons of magnetically charged materials are blasted into the solar system, these storms reach a furious climax. Solar magnetic storms are expected to reach a cyclical high around 2025. They may bring widespread devastation and billions of dollars in damage to Earth. Before this time, we have always been fortunate that these solar storms do not crash with the Earth. However, experts have issued a terrifying warning, which suggests that our good fortune will not endure forever. They claim that the Earth is long overdue for an event the size of the so-called Carrington event in 1859. Stay tuned to the end to learn about the giant solar superstorm and how it will affect the Earth. Research has shown that the subsequent reversal will coincide with solar cycle 24. Half of the solar max will be behind us, with the other half yet to come. Only a week after experiencing what some scientists have nicknamed a solar burp, also known as a coronal mass ejection, the Earth will be subjected to a solar storm. It will be so severe that people who reside near the Arctic or Antarctic circles may witness northern or southern lights during the next 2 days, and the Earth may suffer minor geomagnetic impacts. Unlike specific news stories suggest, this has nothing to do with the ending of the world. As we rightly mentioned, it is entirely expected that a solar storm slams into Earth every now and again, triggering a flood of stories warning of possible disruptions to the worldwide power supply and phone and satellite communication. These assertions might be exaggerated. However, dismissing them entirely as simple alarmism would be a mistake. The National Oceanic and Atmospheric Administration, or NOAA in the United States, categorizes solar storms into 5 degrees of intensity, G1 through G5. The G represents the geomagnetic effects caused by the plasma cloud. Level 5, which happens to be the highest, denotes a significant influence, whereas Level 1 denotes a small result. According to the NOAA, the current solar storm is categorized as G1. Most people will not notice it. The Carrington event in 1859 was Earth's most significant solar storm. On the other hand, only a handful will recognize it as a dazzling natural sight. Charged particles caused breakdowns in North America. European telegraph networks and polar lights could be seen as far away as Rome and Hawaii. Some time ago, the aurora borealis, named after British astronomer and witness Richard Carrington, was observed in Cuba, Australia, and other places. Fortunately, no one was killed during the Carrington event geomagnetic storm of 1859, but there would have been tremendous radiation. There may be some long-term health consequences, but they haven't been thoroughly documented. One of the human race's main concerns should be its effect on our cells and DNA. This will be especially true for people not shielded by Earth's magnetic field, such as astronauts. Aurora, also referred to as the Southern and Northern Lights, is a natural phenomenon that occurs exclusively at Earth's poles when the magnetic field, magnetically charged sun particles, nitrogen, and oxygen combine. According to witnesses, the aurora was so brilliant that people could read a newspaper at night. At the same time, telegraph wires blew out and spontaneous fires were prevalent. More than 100 years later, a solar storm caused outages in areas of Canada in 1989, and electrical distribution system failures put 6 million people in the dark for 9 hours. Because there was no electrical infrastructure back then, the repercussions of a similar-sized occurrence today would be significantly more disastrous. Entire continents may be left without electricity. A powerful Carrington-class solar storm almost missed Earth in July of 2012. If the solar flare had occurred just a week earlier, Earth would have been directly in the line of fire, according to NASA research. While a solar flare explosion in 2003 released massive clouds of solar debris, much of this was absorbed by the Earth's magnetic field, resulting in a geomagnetic storm that distorted GPS signals and radio broadcasts and produced an aurora visible throughout much of North America. The US FAA directed aircraft to fly at low altitudes to avoid radiation exposure. Satellites orbit the Earth in two layers, the thermosphere and the exosphere. Satellites increase their speed 4 times yearly to compensate for the drag effects of particles in the thermosphere and exosphere, which drive them to slow and drift lower. If allowed uncontrolled, they would ultimately burn up in the atmosphere. Solar storm particles, unprotected by our planet's magnetic field, might deposit charge on satellite electronics, short-circuiting them and leaving them unworkable. According to author Sangeetha Abdou-Jyothi, if a mighty solar storm collided with Earth, it would have the potential to not only impair electricity systems and satellites, but also to temporarily disable the internet. The fact remains that our internet infrastructure is not built to endure powerful solar storms. Sadly, if we lose satellite communications, we won't be able to watch TV or communicate in any way, military or civic. And suppose the internet is down in the United States for only 1 day. In that case, the damage is predicted to reach $7 billion in the US alone. Understanding the prediction of events on the Sun's surface and what occurs within the Sun is critical to averting the catastrophic technological failures that will come our way. Us humans need to work together to launch a communication satellite into orbit around the Sun to study its behavior. Suppose solar particles from the coronal mass ejection arrive on Earth with magnetic polarities opposite the closest pole. In that case, they will be pulled together and deposit energy throughout the globe. If the contradictions are the same, the harm will be reduced since they will reject each other. We won't know the polarity of the particles until they arrive on Earth. We can only do so much in retaliation. However, shutting down satellites would mitigate the harm. In a magnificent dance, the long snake-like filament cartwheels its way off the Sun, the scientific instructor stated in his explanation of the footage. Prominence, a filament spun to the Sun's limb, dances high in the corona. It is the size of several Earths. When it comes to flares and CMEs, the Sun's activity is low. Still, filaments and prominences throughout the Sun await their opportunity to explore and join in the fun. If anything remarkable occurs right now, it will undoubtedly result from one of those gigantic strands of solar material and magnetic field. The Sun's activity remains minimal, with just 2 C-class outbursts. An aurora is a natural light show that shimmers in the sky. They are only visible at night and are frequently seen in the lower polar areas. During the peak of sunspot activity, bright, persistent auroras are most apparent. The colors of the aurora change with the altitude and the kinds of atoms involved. They could be red, blue, yellow, and green lights that move and change form slowly, like softly billowing curtains. The most common aurora displays, a green-yellow tint, occurs when ions impact oxygen at lower altitudes. When ions collide with oxygen atoms in the high atmosphere, they emit a red light. Ions hitting nitrogen atoms generate the reddish and blue light seen in the bottom edges of auroras. Although human eyes can seldom perceive this region of the electromagnetic spectrum, ions impacting hydrogen and helium atoms may form blue and purple auroras. Several more auroras were observed on June 22, 2022, and the aurora conditions remain favorable. The NOAA 3-day prediction calls for a G1, a minor geomagnetic storm today. Greater G2 geomagnetic storm will be seen overnight. The forecast is for approximately 4 UTC on July 23rd. That might happen with the advent of a CME on July 21st. If this is the case, auroras might be observed as far south as the northern states of the United States, caused by a combination of high-speed solar wind from coronal holes and the CME hit. On July 23, 2022 at 1843 UTC, a wonderfully organized filament burst from the Sun's southwest limb. It produced a brilliant coronal mass ejection, which was visible in the Soho-Lascaux coronagraphs. The highest, a C1.8, happened on July 24th at 1024 UTC. There are 6 identified active areas on the Sun. We await further investigation to see whether the CME is directed towards the Earth. Do you think the solar superstorm will negatively affect the Earth? Or does the Earth stand a chance to remain safe for the rest of its existence? Let us know your thoughts in the comment section down below. Stay tuned to our channel for more updates of space news coming your way soon, and thanks for watching.